This graph, which is very important for understanding the greenhouse effect, is one which, as far as I can tell, hasn't yet made it out of the scientific literature into popular books on climate change. So let's have a look at it. On the horizontal axis, we have the wavelength of the heat emitted by the Earth in the infrared range. It goes from 5 nanometers up to 50 nanometers. The vertical axis is the radiation energy at a given wavelength. The upper line shows the radiation emitted by the Earth, which would go directly into space if there was no greenhouse effect. The bottom line shows the very much less radiation which does go into space because of the greenhouse effect. In fact, if there was no greenhouse effect, the temperature of the Earth would be about 30 degrees Celsius less than it is at the moment. In other words, about minus 15 degrees Celsius or 0 degrees Fahrenheit. In other words, at least some of the effect of the greenhouse effect is completely beneficial. Now let's have a little bit more look at some of the details. Water vapour is the most efficient of the greenhouse gases. And as you can see, it operates over the complete spectrum of the wavelength over which the Earth emits heat. This graph is actually a little bit simplified. We've shown here one or two peaks and dips in the way in which it traps heat. In fact, there are a whole series of little peaks and troughs across the graph, rather than just a smooth line like we have shown it. This area here shows the heat trapping effect of carbon dioxide. In this area, both water vapour and carbon dioxide trap heat, so the additional effect of carbon dioxide is quite small. In this area, it is carbon dioxide itself which is trapping heat and adding to the greenhouse effect. There is some discussion about where this line is at the moment. Should it be further up? Should it be further down? But what there is no discussion about the fact is that when there is enough CO2 in the atmosphere for it to trap all the potential heat, the increase in temperature of the Earth will be quite limited, perhaps 1 or 2 degrees. This area here shows the effect of methane and of nitrous oxide. Both of them trap heat in a very similar and very small range of wavelengths. Although methane, atom for atom, is a much more powerful greenhouse gas than carbon dioxide, as you can see, it only traps heat over a very small range of wavelengths. For methane, the situation is also a little bit more complicated in that it fairly rapidly decays, and part of the product of the decay is carbon dioxide. So some of its heat trapping effect goes from here to here. I mentioned earlier that it's accepted that the heat trapping effect of CO2, even if the atmosphere has all the CO2 it needs to trap heat in that particular wavelength, will give only a limited increase in temperature. What the models assume is that the effect of CO2 will be to warm the Earth's temperature, and this will lead to increased evaporation from the oceans. This increased evaporation will become water vapour, which, as we have seen, operates over the whole spectrum of the wavelength. and that is the water vapour which will ultimately lead to the higher temperatures.